Hello, it's me again. If you've seen my first video, you'll know that this is video 2 in this series of motor controls and PLCs and things like that. If you missed my first video, it's probably not a big deal. I was just kind of introducing myself and letting you know what to expect and letting you know a little bit about my background and hopefully letting people know, get a sense for whether they're the type of person who would benefit from my videos or not, right? So my name's Steve, and I've got this contraption here, and no, this is not code approved or anything. Of course, that this is might be horrifying to some people who know about motor controls and electrical work, but this is just a few of the things in a control cabinet that we will be talking about. Of course, if you're an electrician, you know that in control cabinets, you probably open up these control cabinets. Maybe you've tried to troubleshoot and oh man, there's a ton of wires and a ton of contactors and a lot of things clicking and, different voltages and transformers. And, there's a lot going on. And a lot of electricians know a lot about that stuff. Like they'll know about the 480 volts coming in. They'll know about the 3-phase. They'll know about the motor contactors, things like that. But there's a niche of electricians who have never learned about motor controls or what goes on in the PLC. They might have seen a PLC. Usually the PLCs you see in industrial environments are bigger than this one. Don't judge me, it's all I could afford. But, and it's good enough for demonstrations as well. So, you might have seen a PLC and you might even had a supervisor tell you, hey, that's the brains, that tells everything what to do. But much more than that, if you're anything like me, I didn't really learn about PLCs until I started learning on my own. And then I realized there's courses and simulators and cheap PLCs and different inputs and outputs that you can buy, and you can learn this stuff. So this series of videos is just for people wanting to get a basic knowledge on motor controls, PLCs, maybe a foundation so that they can decide if they want to take a course and learn more or something like that. Hopefully you will notice over the course of the next, I don't know how many videos it'll be, maybe 10 videos or so. Over the course of the next 10 videos, hopefully you might be inspired to realize, hey, this old local yokel learned this stuff. Maybe I can too. Because it's really just about, there's a lot of information out there. You can get some items like I have and you can practice and you can really learn. So I'm just going to start demonstrating the basics of what is a PLC, what is an input, what is an output, how do we view these things when we're troubleshooting with the meter, what does it look like in the program. I want to reiterate something I talked about last time. I do not want you to think that you're going to learn to program through these videos, because you're not. We're just electricians. But there are a lot of insights as to why you should know what's in the program. And of course, if you want to know the specifics about that, you can watch my last video. But just know that I'm not inspiring anyone to get into programs. You don't want to be that guy that was in the program last when something messed up. But you do want to know enough about what goes on in this PLC that you can troubleshoot around it and that you can ask the right questions and come off as, an expert, so that, you're not just some guy that, well, we hope we fixed it, let's see what happens, but you can be confident and maybe if you don't know what's happening in the PLC, maybe you don't know how to trigger an output to troubleshoot a circuit. So maybe you need to learn that, hey, there might be a timer or a counter, or there might be some sort of delay in there, and it might kind of help you to learn how to troubleshoot when you're trying to use inputs to trigger outputs to figure out what's wrong with the control circuit or something like that, okay? So I'm going to reduce this contraption. Like I say, it's not everything in a controls cabinet. It's just pretty much a simple sampling of some of the controls, right? So anytime you have a PLC, you're going to need some sort of power supply. And I've seen a lot of different PLCs with different power supply requirements. So if you do buy a PLC, you do want to get the appropriate power supply for the PLC. This PLC, these Schneider Zero Logic PLCs, are pretty affordable. They're pretty good for trainers, to train yourself. And the ones that I've seen Zelio Logic PLCs in my program. Some of them need 12 volts, some need 24 volts, some need 120 or 240 volts. So there's a lot of PLCs that I've seen in the real world as well as on my program that have different requirements. So if you get a PLC, just know that your power supply needs to match up with the requirements, not only in voltage, but wattage. You want to make sure that you're not going to burn up a power supply. Although power supplies aren't as expensive as PLCs, you want to make sure you don't burn something up or screw something up. So you want to make sure everything's appropriate, right? So we have a power supply. This one's DC. So just like your car battery in your car, our positive on our DC is red and our negative is black. Our DC feeds this PLC right there. That's 24 volts. On the top, I have inputs, and on the bottom, I have outputs. Inputs, you might have heard, you might know about input devices, whether they're sensors or push buttons or toggle switches or limit switches or float switches or, all kinds of sensors that tell the PLC what is in the environment. It's pretty much an input, right? And so my inputs go here. They send a signal to tell the PLC what's going on in the environment. And then based on what's going on in the environment, the PLC will decide the outputs. Don't get stuck on my simple inputs and my simple outputs. These could really represent anything. This is just for demonstration purposes. These are just samples. I've got some momentary push button inputs. I've got a toggle switch input. I've even got a potentiometer input that simulates analog voltage. I've got some photo sensors on the side. So I've got a few different inputs, but like I say, you can almost use anything that senses and sends a signal about the environment for an input. So there could be endless other possibilities of inputs as well as outputs. These are just lights. They're easy for you to see. It's easy for you to see when I trigger an output. That's why I did it that way. But if I had three-phase service in my house, I could easily hook up three-phase to this motor contactor and hook up a motor, or outputs could be anything electrical that does something that you need it to do. So just know that I have some inputs and some outputs. I have a power supply, I have a PLC, some contactors. You're pretty used to seeing those, I'm sure. One thing about the inputs is it does kind of matter how you wire them. There's two different ways that I know of to wire inputs. It's called syncing or sourcing. I don't want you to get it bogged down on that technical term. Just know that that is a term. Don't be surprised if you ever hear syncing and sourcing. But what that means is, are we hooking our negative side of the DC circuit? Are we sending our signal as a negative signal or a positive? Is our signal on the positive side of the DC circuit or negative side, right? These are all red, they're all positive, and the reason why is, first of all, this Zelio Logic PLC requires that, and so I didn't want to do something like that the manufacturers don't say to do, so I just did my positives, like the manual says. But so that's, sometimes you're just stuck with, needing to do it one way or another. But there are some PLCs that have a common, and you can wire them either way. Where that really matters is with things like your photo sensors. Some sensors are called syncing or sourcing sensors, and what that means is, well, for example, these are PNP sensors, and I know I'm throwing out jargon, just bear with me. This PNP sensor means it needs a positive and a negative for the sensor to work, and then that second P means it's sending the signal as an input as a positive. So, of course, if I have PNP sensors, all my inputs need to be positive. If I had what's called an NPN sensor, you probably guessed it, that second N means that it sends the signal as a negative. So my inputs would need to be negative. So just know that if you're ever troubleshooting a PLC and you see the positive or negative on the inputs, don't be thrown off if one PLC is one way versus another PLC. It might just have to do with what kinds of sensors people have, as well as if you get into a situation where you have a bad sensor and you have to replace the sensor, make sure that you replace it with the appropriate sensor. If you have a lot of positive inputs, you want a PNP sensor, and if you have a lot of negative inputs, you want an NPN sensor. Of course, they do make universal sensors, but even that, it's just got two wires, one's negative, one's positive for the signal, and you got to know which one to hook up. So just know that it does matter how you wire these inputs in, and this is on the positive side. My outputs, I've got 4 outputs. It's pretty self-explanatory. When the PLC processes inputs or certain combinations of inputs, it will basically close a contact, and it'll send from my 24 volt positive feed to my, what I call my switch leg, which goes over to my relays, which, you know, switches the line voltage and, you know, keeps the line voltage going on to my outputs, right? Pretty much. So that's pretty much the also, I do actually have some analog inputs. Not every PLC has analog inputs, but I have 4 digital inputs and 4 inputs that could be either digital 24 volts or they could be analog 0 to 10 volts. So we will get into some analog stuff. It's a little bit different. I don't know that I had a lot of experience with analog until I tried to troubleshoot my car and realized, hey, there's different voltages, or you know, I tried to you know, I got self-employed and realized, hey, I don't know that much about DC and analog. So that's something that I've learned through the years. So if you want to learn about analog, we do have some analog inputs, and we'll touch on that. As far as the PLC is concerned, this cable's pretty important. You can download, you make a program, you download it on here. You'll see me with a lot of simple programs that I use for demonstrations. I use this cable to download the programs on it. Now, you didn't hear this from me, but if you're ever in a position where you have access to a program and you're ever thinking you might want to change something, I would highly recommend you not, because you don't want to be that guy that screws it up. But if you happen to get into a program and mess with it, download a copy of the original, so that if you screw something up, you can at least upload what you had before, and it'll keep you out of some hot water. So this can be used for downloading or uploading, although I would not recommend an electrician to be a programmer. Remember, we're just learning about this, not learning to do this. As well as this cable is good for, you're going to see me, I'm going to use it to show you what's going on. You have a monitoring mode. These PLCs can hook up to the internet, to a supervisory system called a SCADA, SCADA system. A lot of industrial environments and a lot of environments will have a system where people can remotely monitor things. It's pretty cool. So that's another reason to have a PLC. Which brings me actually to, if you're ever in a position to troubleshoot, sometimes a maintenance supervisor might know what you need before you do. So that might be a good person to have as a friend, because, you know, they have a lot of machines, and if something goes wrong, they may look on their SCADA system and say, hey, wait a minute, we should be getting an input here. Maybe there's something wrong with my input device. And so if that person's a friend of yours, it might help you with troubleshooting, because they can give you a sensor and say, hey, go check the line voltage of the sensor, and if the sensor's bad, change the sensor, and it could really help you to act like you know what you're doing and to feel confident and to learn. And so just know that sometimes those monitoring systems can be used to really help you to troubleshoot. Don't be afraid to ask for help, because we're all just trying to get a job done here, and we don't really want to inspire anyone to screw up, right? So the cable's important, and know that people can be monitoring, you can upload, download, all kinds of cool things. So I think that's pretty much the nuts and bolts of the PLC and motor controls. Next video, I'm going to show you some examples of inputs and outputs being tripped, and what that looks like if you're troubleshooting it on the meter, or maybe even what it looks like in the program, so that you can just kind of have a better knowledge of what's going on. So next video is going to be real simple. It's just going to be basically about the control circuit and inputs and outputs and how they work. Okay, thank you. Have a good day.